Welcome to our lesson for Unit 2 or Week 2 of our lecture, which will cover the topic about inserting, updating, deleting, and selecting records, as well as the use of SQL operators. By the way, this is just a review of our previous lessons that we did last semester. So to get us started, let us review about the syntax for inserting records in SQL. Now, the syntax for inserting records in SQL is insert into name of the table, followed by values, open close parentheses, what are the values that we want to insert. Now, take note, again, we will be using both SQL Server and MySQL. For this example, we will make use of table sample that we have created in our previous lecture. So for this one, okay, I have already created table sample both for MySQL or MariaDB and SQL Server. Now for our insert sample under SQL Server, we will insert the following values. So 1 will be the value for our S name, amount is 1.3.44, unit is 1, and price is 150.65. So let us run the code. Okay, so our code ran successfully. For MySQL, there's a little bit of difference with the code because we are going to include the actual column name. The actual column name is required. MySQL will not work with the same code as SQL Server. This is needed in order for us to avoid using the SID column, which as we know is already an auto increment column. However, we need to specify the particular columns that we have to insert into in MySQL. If we try to insert this record, okay, so there is our record. But what will happen if we try to insert using this code? Okay, as you notice, column does not match value count at row 1 simply because it under MySQL it includes SID as one of our required columns. So I need to put particular value here in order for this data to be inserted. However, if we want to automatically have a value of SID, we need to specify the particular columns needed. So for SQL Server, it will also display the same value. Next, how do we insert rows with null attributes? So basically, we are using the same syntax. However, for the column that we will not place a value into or will have a value of null, we need to insert the word null. Okay, take note, if you are going to use this style of inserting, you have to make sure that the column accepts null, meaning it doesn't have the not null attribute in that particular column. Otherwise, we will encounter an error. So for example, if we are to insert in SQL Server. Okay, notice I inserted null. Let us try if this will run and then select the data. Notice that our unit is null. For MySQL, again, we have to declare the particular columns. Okay, and run the command. Okay, and that is how you would insert a null value into a column. Okay, now how about if we just want to insert rows with optional attributes or optional columns? In this example, what if I just want to insert the S name and the S amount? Now this code both works for SQL Server and MySQL, but do take note again that all the columns that you have not included in the insert statement should allow null because they will have a value of null. So let us change, for example, this one into John. Okay, run and then select. Notice all the columns that we have not included in our statement will have a value of null. The same goes for SQL Server. Okay, next, select statement. So as we have learned, if you are to perform a select statement, you use the keyword select followed by the column or columns that you want. If you want to include all the column, you use the wildcard character asterisk to include all the column, followed by the keyword from, followed by the table name. So in these two examples, we are selecting columns S name and S amount, and we are if we want to select all the columns, we use the asterisk. Okay, so I will not go into that example anymore as it's very basic. Next is a review on the update statement. Now, for update and delete, always remember that although the where condition is optional, you must always have the where clause in order for you to avoid updating or deleting or removing all the records in your table. So you have to be careful in executing this. Actually, in SQL Server and in MySQL, as well as all the other uh, DBMS software, they have some sort of like a feature wherein you are not allowed to update or delete without using the where clause. So if you are actually using uh, Workbench or Management Studio, you might encounter that particular feature under the options or settings menu of the GUI. Now, again, this is a review. If you are updating a particular column or multiple columns, you need the keyword update followed by the table name, followed by the keyword set, followed by the column name, and then equals the expression. And then if you have multiple columns, you can separate them using comma. Okay, just don't forget the equivalent value. Take note, if you are updating amount or numbers, there should be no single quote. If you are updating string or date, there should be single quote. So let us try to do this example. So for example, I want to update all the amount to 255.2 wherein our S name is 1. So let us first check. So we have two ones here. So we are trying to update the amount into 200 plus. So let us try to run. Okay, if we try to check, okay, notice that because all of my S name is 1, all uh, all the S amount will become 255.2. Okay. For this one, we have one S name of John. So let us see for MySQL what will happen, how many are affected. So notice only those having an S name of 1 is affected. Next, delete statement. So delete and update are almost the same, wherein we need to set a particular condition. However, always remember the syntax for the delete statement. It is delete from table name followed by the where clause. Take note also that we do not use any asterisk for the delete statement. Only delete from table name. So let's say, for example, we want to delete all the records with an S name of 1 here. After executing, we should have only one record, which is John. Okay. Okay. Now, for this example, we are going to be using two tables, namely table food and table cake. Now, for this topic, we are trying to insert rows from another table. Okay. So, one requirement if we are going to do this one is that first, we need to make sure that the table you are inserting has the same number of columns to the table or to the table that you are selecting. Okay. Second, they should have the same data type. So in this example, let me show you. I have table food and table cake. Okay. These are the columns. Okay. So what will happen here is just I will insert two records in table cake for name and date. And then I will insert that into table food under the FD name and FD date of table food. Okay. So take note when you are inserting date in MySQL, the format that is usually used is year, month, day. You can also use this format for SQL Server so that you will not get confused. Just use the same date format. So let us try to run this example for that. Okay, okay, sorry for that mistake. Okay, so do not forget to add the primary key. For our example, I have already updated this one. So next is we try to insert okay, our data into our table cake column. Need to create table cake. Okay, okay. Sorry, have to increment again. Increment, run. Okay, so now have the two tables. Then we insert our data for table cake. So we have choco and mocha as well as the date. Okay, again, I'm sorry, we did not include the column name. Okay, again, sorry for that one. So I have inserted the columns as well as the data. So let us try to run. So let us check. Okay, we now have two records for table cake. How about table food? Table food has no record yet. So what are we going to do? We are going to insert the data from table cake into table food using the CK name and CK date column values. Okay, so it will be placed inside FD name and FD date. Let's try to run and let us check. Okay, so there you go. We also have Choco and Mocha, and under FD date are the same CK team and CK date from table cake. Notice that price and quantity are null because we did not provide any value for that. And that is how you would insert a data from a table to another table. Again, be reminded what are the requirements. First, you need to have the same number of columns. So in here, we have two. Second, we need to make sure that the data type of and the order of the columns are the same. So string, string, date, date, and then you have if you have amount, should be amount also here under the select statement. Okay, next are select queries. So select queries, as we have learned, can select either multiple columns or all columns using the asterisk symbol. Okay. The select queries can also have a where clause in order for us to filter out certain data. So in here, we have an example. Okay. So we will select all the name and date from table food wherein the FD name is equal to Mocha. So the syntax for that is the same as that of SQL Server and MySQL. So let us try to run that. So after running, we are returned with one particular row. How about if we change this one to not equal to Mocha? So all the returned rows should not be Mocha. So there you have it. It's Choco. Okay. Using comparison operators and character attributes, take note, string comparisons are made from left to right. This left to right comparison is especially useful when attributes such as names are to be compared. For example, the string Ardmore would be judged greater than the string Aronson but less than the string Brown. Such result may be used to generate alphabetical listings like those found in a phone directory. If the characters 0 to 9 are stored as strings, the same left to right string comparisons can lead to apparent anomalies. Why? Because, for example, the ASCII code for the character 5 is as expected, greater than the ASCII code character for 4. Okay? So string 5 is greater than string 4. Yet the same string 5 will also be judged greater than the string 44 because the first character in the string 44 is string 4, which is less than 5. For that reason, you may get some unexpected result from comparisons when dates or other numbers are stored in character format. So to simply illustrate this one, let me show you this statement. Select. Okay. Okay. Let's try to run these examples. So 5, string 5 is greater than 4. That is true. How about this one? That is still true. Okay. So because the strings are compared one by one from left to right. Okay. Next, comparison operators and dates. So we can compare the dates. You just have to make sure that they are enclosed in single quotation. So take note, the format for date under MySQL is year, month, day. So I advise if you are using MySQL to use this format as much as possible. So let's try to run this example. Okay. So both The two data are returned because they are greater than 1990. How about computed columns and alias? So again, computed column and alias are those columns. When you say computed columns, it is a column derived from two or more columns that are processed together. For example, in this example, we multiplied price by the quantity, which will return another column or another value for the column. For alias, on the other hand, we make use of the keyword as followed by the string, which will take over as the column name. So that is just the purpose of alias, to serve as a column name. Okay, we try to run this example. Check total. So as you can just ask keyword, you could also just use a space, but the ask keyword is better, or this will serve as a reminder that that is an alias. We could also use a computed column or a, alias and data arithmetic in a single query. For example, we want to get the list of out of warranty products that have been stored for more than 90 days. In that case, the FD date is at least 90 days less than the current system date. In order to do this one in SQL Server, we make use of getDate function, which returns the current system date, and then the date add, which is a TSQL function that adds a particular date interval from a given column or value. It accepts three parameters. Number one is the date type, such as year, day, hour, minute, etc., comma, followed by the integer value, followed by the column name or date value. Take note, you could also use the date add to subtract a date from a particular value, date value, just by giving a negative integer value. So in this example, we are going to get the FD name and FD date, wherein the FD date should be less than or equal to date add day minus 90 from the current system date. So in order for us to do that, okay, we will paste our code and then try to run it. Okay, so it returns 2 days or two dates. I'm sorry. Now, what if we want to return only this particular record, which is 2001? So let us try to change the system date or get date into, for example, 2010-1-1. So January 1, 2010. So after running the example, we will only be left with the FD date of 2001. Now, if we want to do this in MySQL or MariaDB, we need to do the following changes. First one, it doesn't have any get date, but it has what we call cur date, which is the same. It returns the current system date. Next, we have the date sub, which subtracts the date from a given interval. It accepts three parameters. Number one is the column or date value. Next is the keyword interval followed by the integer value. So take note, this is sub or subtraction. And then lastly is the date type such as the year, day, hour, minute, etc. So in our example, we can convert the code into where FD date is less than or equal to date underscore sub cur date, comma, keyword interval 90 days. So it will subtract 90 days from our system date. Then we also have here an example using January 1, 2010, which subtracts 90 days from January 1, 2010. So let's try to run this example. Okay. So we are left with, again, two records because all the dates are less than the current date today. Now, we could change this one to January 1, 2010, in order for us to only have one particular record. So this particular record, Choco, will be removed. Okay. So that is how you would use the date sub and the date add function. Always remember that if we are using rules of precedence, which is the arithmetic operators as well as the symbols, including parentheses, what will be performed first are the operations inside parentheses, followed by power, followed by multiplication and division, and then lastly addition and subtraction. Now, one thing to check the result that happens if we are to make use of parentheses or rules of precedence is this example. The first example returns for both SQL Server and MySQL 4. When we execute this particular operation, 3 times 4 divided by 3 minus 1 plus 1 returns 4. Whereas if we use rules of precedence using parentheses, for SQL Server, it will return 1. For MySQL, it will return 2. Okay, what is the reason behind this one? Okay, let us try to check. First, perform the creation. SQL Server returns 4. MariaDB or MySQL returns 4 also. How about the one with the parentheses? Okay, it returns 2. For MySQL, it returns 1. Now, why did this happen? Let us try to break down because both the answers are correct. Okay. They are both different, but they are both correct. What happens here? Under SQL Server, if you notice, 4 divided by 3, that is equivalent to, let me grab a calculator. 4 divided by 3 equals to 1.333333 something. So you subtract 1. And then it just returns 0.333333. And then you add 1. That's equivalent to 1.333333. Okay, I'm sorry, I got lost. Should be multiplication before adding 1. Okay, so 0.3333. Okay, okay. 1.33 divided by minus 1. Okay, so times 3. And that is equals to 1 plus 1 equals to 2. Now, using calculator, it will return 2, which is the same as our example in MariaDB. So, why the hell did MSSQL return 1, and why the hell am I saying that the answer of 1 is also true? What happens here is that inside MSSQL, when you divide 4 divided by 3, the answer will become 1.33. So instead of using the whole numbers, it truncates the number that it sees. So instead of 1.3333 something, what happens is that it becomes 1.33, if I'm not mistaken, minus 1, so 0.33. Then you multiply it into 3, becomes 0.99 plus 1. That becomes 1.99. So because we did not specify a particular data type in this example, meaning to say we did not specify if it is decimal or integer, SQL Server uses the default data type set in all of our examples. So because we are using integer, MS SQL drops the decimal part of our operation and retains the integer part, which is 1. So what happens is that the answer becomes 1. Okay. Now, if we specify the data type used, for example, I change our values to this one, see what will happen. Okay. Becomes 1.99999, which is actually the correct answer. So if we use this particular data type and then you compare it to MariaDB, which outputs an answer of 2, you can now say that MS SQL is actually the better answer. So it's really depending on how you code your answer. So both of them are correct. MS SQL outputs an answer of 1, MariaDB outputs an answer of 2. Both are correct, depending on the particular data type and the presentation that you have inserted in the particular database management system. But they handle the data differently. Always remember that they handle the data differently. How about if MariaDB, if we perform the operation with decimal places, what will be the answer? The answer will still be 2. Okay. So next, logical operators and or and not. Always remember, if you are using or, it will return either of the condition. If you are using and, it should have both of the conditions. And you can also mix match all the two conditions. If you're using not, it is the reverse. So let us try to test our example. So for example, not will return choco. Of course, it is not mocha. What if we try to do the or? It will return either choco or the particular date that you have requested. What about end? Okay, okay, let us try to remove. Okay, will not return anything because it requires both of the conditions to be true. Okay, so not, here again, by not will return choco. Next, special operators. So we have between, which can get the values between two particular, the values between a column value between two particular values. You can make use of date, you can make use of string, you can make use of number. Okay, so we have an example here. Every date is between these two dates. Okay, you could also make use of an example using string. For example, kakain. Let's try this example. Okay, it returns choco. But what if O, what is greater than O element OP? So for example, we use P. and P. Not return anything. So we could also use between four strings. Date. Okay, we could use that for date. Is null. Basically, it just checks if the value of the column is null. Okay, there is no record for FD name, which is null. How about FD price, which is null? FD price. Okay, okay. There is two rows. Okay, for the like special operators, we have four particular patterns that you could use. The first two pattern, which is the percentage and the underscore, both works for SQL Server and MySQL. Percentage symbol pertains to any and all following or preceding characters which are eligible. So for example, when you say J percentage, it uses like, by the way, percentage and underscore uses like special operator. So for this one, J percentage will include Johnson, Jones, Jenigan, July, J-231Q. Whereas JO percentage will include all that has JO before any character. So for example, Johnson and Jones. And then percentage N means all characters at all characters or all values as long as it ends with N. So for example, we have Johnson and Jernigan. So percentage can mean one or more characters. Whereas if we use underscore, it may only be substituted by one particular character. So for example, in this example, we have underscore 23-456 something something. The first underscore can be substituted with 1, 2, 3, 4, 5, etc., etc. Whereas in this example, we have two underscores, so this can take on any particular value. As well as this one, underscore O, underscore ES, so it can have the following values: Jones, cones, coke, totes, rolls. So let us try to do the examples. For example, we have the percentage symbol. For example, we want to get all the FD name rows that has the letter O. So first is under MySQL or MariaDB. Let's try to run using like percentage O percentage. So everything that has O in the middle. And then for SQL Server, the same code. Okay. How about we want to return all the FD rows that has any letter in between CH and CO. So CH and CO, such as Chaco, CH Biko, etc., etc. So let us try to do that under MS SQL. So we have Choco. And then under MySQL, we have also Choco only. Okay. Now, for SQL Server, we have two pattern matching sets or pattern matching symbols. The first one is the curly braces, the braces, which means any single character within a range or a set. For example, T braces E dash I, which includes all values having letter T followed by E up until I. So that's E, F, G, H, I. So we have T, E, T, F, T, G, T, H, and T, I. How about this one? We have T, A, E, I. So this is a set. It means it could either be T, A, T, E, or T, I. Okay. We also have another pattern, which is the caret symbol, which means any single character not within a range or a set. Basically, this is the reverse or inverse of the example I have showed earlier. So we just put the caret before the particular set or value or range. For example, T caret E dash I. So all values except for E to I. So we have TA, TB, TC, TD, etc. except for TE, TF, TG, TH, and TI. So we also have A caret 1, 2, 3. So all values A0, A4, A5 except for A1, A2, and A3. Now, for MySQL, we do not have the like pattern together with the um, braces and the braces caret. Instead of doing that, or instead of using that, we have what we call regexp or regular expression. Regexp stands for regular expression, followed by the braces, or regexp followed by the braces caret. So this will not use the like operator. Instead of using like, we are going to use regex in MySQL. So it basically has the same pattern except that we add the word regexp and replace like. So for example, I have here for SQL Server, we will find all the FD name rows that has any letter in between A, E, I, O, U, such as Choka, Chose, Chosi, Choko, Choku, etc., etc. So this is the code for MS SQL. So we use like and then followed by the particular pattern that we want to display. So this will return Choco. For MariaDB or MySQL, instead of using like, we use regexp. It will return again Choco. Next, we want to add, I think we also have another value here. Okay, notice B, Choc B. We added Choc B in the set. Next, we make use of the braces caret symbol. So again, it's the same. You just replace like with regex. So we will find all FD name rows that has any letter except for A, E, I, O, U in between, such as Choc B, Choc C, Choc D, Choc F. So let us first try the MySQL code. So this will only return Choc B. Okay. For the SQL Server code, okay. So we have no I'm sorry, MS SQL. Okay. Okay, so that is our pattern. Take note, if you are to use the like in MariaDB or MySQL, it will still run. However, you will not get your desired result because MySQL will not know that this is a regular expression pattern. It will treat this one as this particular value. Let me show you. Okay. we have added that one. So if we try to run this one using the like operator, it will return this one. So basically, we are just asking MySQL to return this particular value, not pattern, if you use like under MySQL. Okay. So next, we have the in special operator. So the in special operator can be used instead of using a long or code, we could pattern it like this one. So we're FD name in Choco, comma, Mocha. So it's the same equivalent as FD name Choco or FD name equals Mocha. So let us try to run the sample. So this example both works for SQL Server and MySQL. Okay. And then lastly, exist. So as we all know, exist is a special operator that can be used whenever there is a requirement to execute a command based on the result of another query. For example, if a subquery returns any rows, run the main query. Otherwise, do not run it. For example, the following query will list all the data from table cake only if there are FD price from table food having a price greater than 5. So it will return all the values from table cake if there is a value from table food wherein the FD price is greater than 5. So let us try to run this one. So it both works for MS SQL and MySQL. Okay, there's no FD price is greater than 5 under table food. So let us check. There is no price. Okay. So if we try to change that, let us try to date table food set price equals to 10. Okay. Try to run. This will return a record. Okay. So because we have updated the price to be greater than 10, we can now return the values from table cake. So the same goes with MariaDB. The same syntax will also work. Okay, so there you have it. The lessons for our week 2. Thank you and good luck.